Hello all. So in this video I am going to explain about Codeforces Educational Round 131 C problem. So schedule management. In this problem there are n workers and m tasks. The workers are numbered from 1 to n and each task I has the value ai. The index of worker who is proficient in this task. Every task should have a worker assigned to it. If a worker is proficient in the task, they complete it in 1 hour, otherwise they will complete it within 2 hours. The workers work in parallel, independent of each other. Each worker can only work on task at time, only one task at time. Assign the workers to all tasks in such a way that the tasks are completed as early as possible. Okay, they started at the 0th time. So what is the minimum time all task can be completed? So we want to find the minimum time required to complete the task. Okay, I will explain the example and question in the explanation. Okay, let's take the example. So there are 4 test cases. First test case is there are 2 workers. Okay, consider this worker. This is one of the worker and this is one of the worker. There are 4 tasks. Okay, task 1 and 2 and 3 and 4. There are 4 tasks. Okay, that in task 1 this is first worker. Okay, this is first worker, this is second worker. Okay, in task 1 the first worker is proficient. Okay, he completed within 1 hour. Okay, he in task 3 also the first worker is proficient. Okay, and in second task the second worker is proficient, and also in fourth task also he will complete it in 1 hour. Okay, so in this way, in this problem, the optimal way is the first worker first start with either one or third task. For example, he started with this task. The same time, the second worker start with this task or this. Okay. After 1 hour pass, he will switch to the third job because it is the proficient way, and also the second worker will move to this fourth task. Okay. So this is the first example. Now move on to second example. Okay. Okay, wait a minute. Okay, in second example, there are again 2 workers. Okay, okay. In this time, the first worker is proficient to all tasks. Okay, task 1, task 2, task 3, task 4. He is the only man who is proficient in all tasks. He is take only 1 hour to complete each task, but the second person will take 2 hours to complete all 4 tasks. Okay, so now the optimal way is to he first start this first task, so it is 1 hour, and again start his second task. This take him to 2 hours to complete. Okay, now 2 hours is complete. So the same time, while the first worker started the first job, the same time the second worker must want to start the third job. So he will take 2 hours to complete this task, and fourth job will be taken by this first person. So it will take him to 1 hour. So totally 3 hours. So this is the minimum hours to complete this. The same way, in the next example there are 5 workers and 5 tasks. Okay, each person is specializing in each task. So we can assign each task to each person. So it will complete it within the 1 hour. Okay. The same way, in the final line, there is only one task and only one person. Only one person. He is the one who is who is professional in that. So he will complete the task within 1 hour. So this is the example. Okay, while seeing this problem, many of you think it can be solved using greedy approach, but it is not. Okay, if you solve this kind of problems yearly, you can identify which type of problem is this. It is just these problems come under binary search. You can easily solve this by binary search because you know the lower bound and upper bound of this okay problem. Okay, maybe either we can complete this problem in we know the minimum number of time required to complete this problem or maximum number of time, and also we know the verifying time, how to verify. whether our time is correct or not, our estimated time is correct or not. So it can be easily verified. So this properties are satisfied for this problem. So it can come under binary search. Okay, now let's explain the binary search algorithm to solve this problem. Okay, I will erase all that. So now I take the uh, second example to solve this problem. So now for this, in my best case is I want to first in binary search problem I want to find the best case. Okay, in this problem the best case is always, so it can be maybe solved within the so slow can be solved within 1 hour. Okay, it's the best case. In worst case, okay, or high, okay, high h. In worst case, it may be solved in, okay, it's 4 into 2. Maybe only one employee is there. He must want to complete all tasks. So it will take, he is not proficient at any task. Okay, consider, let's imagine. He is not proficient at any task. So he takes 4 into number of tasks into 2. So 2 into task. Okay, 2 into task. Now um, we want to uh, reduce this to, we want to do binary search with this bound range. Okay, now I want to find a middle. Okay, normal middle concept. Okay, now if I do middle, for example in this problem, so 1 plus 8 is 9. So 9 divided by 2, 9 divided by 2 equal to 4. Okay, so now I estimated whether it might to complete the task may at least need 4 hours. Okay, now I just want to verify that. Okay, to verifying this is the main concept of this problem. So whether I want to check whether 4 hours is enough to complete the all task. Okay, now I check the first task. So it is now before editor I want to find out the which employee is proficient at how many tasks. Okay, for example there are 2 employees. Okay, in first employee is proficient at 4 tasks. Okay, in this problem consider this. Okay, first employee proficient at 4 tasks and the second is proficient at 0 tasks. Okay, I know he's, so now the first employee is proficient at 4 tasks. Okay, now I'm going to iterate over this. Okay, now I take the first 4. Okay, now he's completed, he's need 4 hours to complete the job. He's proficient on. So it is equal to this. Okay, middle. Okay, now my extra needing, okay, it is important. Initially it is 0. Okay, now my extra need, okay, my completion time is 4 hours. So his assigned work is only 4 hours. Okay, he can complete within his best time. Okay, so it can be satisfied. So there is no extra need. So 4 minus 4, it is 0 only. So there is no need more time to him. Okay, in the second there is only, he has no job, so there is 0. But he can, now he have 4 hours. Okay, he have 4 hours, he do nothing in 4 hours. So we want to assign to him. So to assign to him job, we can assign to him here. How many jobs we can assign? We can assign n by 2. Okay, 4 minus 0, he has 4. Okay, extra hour is he has 4 hours. We can assign him, he can complete it to one task within 2 hours. So we can assign him 2 tasks. Okay, so we can do minus operation. Okay, he can, need is now going to minus 2. Okay, now need going to negative, which means we can easily complete this task within the 4 hour. Okay, some workers may be in rest also that time because it is need is negative. Okay, now we know, okay, now we know that our need is become negative, which means this is one of the answer, but it is not the optimal one. Maybe there in future there are some answer also in optimal. Okay, if need, okay, if need less than or equal to 0 means I want to reduce the higher upper bound. Okay, because it is enough to complete this task within this middle point. So I want to h equal to, I want to move the highest point to middle. Otherwise I want to move in else I want to increase the lower bound to mid plus 1 because I need more hours to complete this. Okay, finally I print the lower bound. Finally I print the upper bound. Okay, right? So this is the answer for the final output. So in this example, the 4 is enough because it has become negative. So it is enough. Now I going to I reduce the higher point to 4. So okay, now low is 1, high equal to 4. Okay, and now the middle point now become 4 plus 1. So 4 plus 1 become 5. So 5 divided by 2 is 2. So now I check whether I can complete within the 2 hours or not. Okay, first I will go check whether it's so it takes 4 hours to complete it, but we just have 2 minutes. So we need extra 2 hours to complete him. Okay, so we need 2 extra hours to complete him the job. Okay, need become 2 hours. Now again we will check the second worker. He has 2 hours, 2 minus 0, he has 2 hours left. He is free in 2 hours because he has no job. He has now 2 minutes, 2 hours. Okay, within the 2 hour he want to complete, he will check. Okay, he want to complete, in one, within the 3 hour he can only complete one job. So 2 minus 1, it will become 1. So need is 1. So within 2 hour we cannot complete all job. We pick, there is one bending job will be there. Okay, so now I want to increase the low pointer. So now I increase the low pointer to middle. So middle is 2. So now will become low equal to 2. So high equal to 4. So 4 plus 2 now we become, so now middle become, so I will erase that. Okay, now low equal to 2 and high equal to 4. Okay, so now mid equal to 6. Okay, now whether I can complete within the, sorry, middle equal to 6 divided by 2 equal to 3. Now I want to check whether I can complete within the 3 hours. So one job will take 4 hours and second employee take only 0 hours. So within 3 hours he can complete 3 jobs with need become he need 1 hour extra. Okay, but in second employee he has 3 hours. He can complete this task within 2 hours. So need become negative 1 because he will complete the, but extra 1 hour is there, so it will be minus 1 with this. So need will become negative. So need is negative means uh, so it is one of the answer. So we will update the higher point. Okay, then we do this operation until low high cross the low point. Okay, then we abort the process and we will print the highest point. So this is the concept. Now I will explain the code. Okay, so this is the code. So first I will take the inputs, and after taking the input I will just count the frequency of the proficiency of the workers. Okay, I count how many workers are proficient at the job, which jobs are proficient to which worker. Then I will reduce low and high. Okay, I already explained. Low equal to 0, high equal to 2 into the number of tasks. M means task. After that, low less than high, it's normal binary search template, and it's a need equal to 0. If the counter is okay, if the frequency is less than mid, which means he has more jobs. Okay, he has extra time. So the extra time will be become will be my extra. He has extra time, so it will be reduced from the need. Okay, if the time is not enough for him, so it will be increment to need. Okay, after this operation we will check whether the need is negative or not. If the need is negative, it's one of the positive case. We update the high equal to mid, else I will increment the load to push more hours. Okay, finally I will print the high of the finally I print the high. Okay, this is the concept. Now let's submit this. Okay, choose one. Okay, this is accepted. I did not solve this problem while in the contest, so I finally solved this. Okay, hope you are enjoyed this one. So if you have any doubt, please kindly ask in the comment section. Thank you all.